IEC 62443 made clear. The industrial cybersecurity standard, explained in plain language and built to be easy on the brain. The whole thing in one sentence. IEC 62443 is the international rule book for protecting industrial control systems from cyber attack. That's the centre of it. Everything else is detail that supports that one idea. In plain words, it's how to keep the factory's computers safe standard. Picture this. Before we introduce any jargon, hold one picture in your head. Imagine a factory as a building. Inside are rooms. Each room holds equipment that does a similar job. Between the rooms are corridors and doors. Some doors are more sensitive than others, so they need stronger locks. IEC 62443 is simply the method for the 4 free decisions. Those decisions: number 1, which equipment goes in which room? These are called zones. Number 2, how the corridors between rooms are controlled. These are the conduits. Number 3, how strong each lock needs to be. These are the security levels. Keep this picture. The rest of the guide just adds names and detail to it. So why does it exist? Normal IT security protects information. Its top priority is keeping data private. Industrial security protects physical processes. Its top priority is keeping things running and keeping people safe. A leaked spreadsheet is bad. A hacked pump, valve or power supply can hurt people or halt production. So industrial systems need their own rulebook, and IEC 62443 is that rulebook, and it's now backed by law. Regulations such as NIS2 and the EU Cyber Resilience Act point directly at it. Let's look at some terminology, the words you need to know. IACS stands for Industrial Automation and Control System. This is the factory's control computers, networks and devices, the thing that's been protected. So just to recap, IACS is Industrial Automation and Control System. Another term you need to know is OT. Now OT is operational technology, which is the technology that runs the physical equipment, versus IT, which runs the information. Next, asset owner. Now the asset owner is the operator who owns and runs the system, e.g. the factory or utility. The next term you need to know is integrator. Now integrator is a company that designs and builds the control solution. Next, product supplier. The company that makes the individual devices that go into it. Now we're going to come on to a term called SUC. That stands for System Under Consideration. The exact boundary of what you're assessing, what's in, what's out. So when you're assessing, you consider the system under consideration. Now we're coming on to some more important terms. Zone is the next one. Now zone is a group of equipment with the same security needs. For example, a room. A conduit. Now conduit is the controlled communication path between zones. A corridor. So conduits could be wired, which is what people traditionally would think of IEC 443 in terms of conduits, Ethernet connections between points, but you also need to consider the wireless aspect, which a lot of people don't consider. There's a lot of wireless signals in many businesses, and you need an assessment to check whether they're encrypted, they're not encrypted, what exists, etc., because that all forms part of the conduit. Just a reminder, the conduit is the control communication path between zones. The next term we're going to look at is SL. Now that stands for security level, how strong the protection is, and this is ranked from 1 to 4. The next one is FR. Now FR stands for foundational requirement and is one of 7 basic security building blocks. The next term, ML. Now ML stands for maturity level, how reliably and repeatably your organization does the work. And finally, CSMS. Now CSMS stands for cybersecurity management system, the program an asset owner runs to manage all of this. Now we've looked at some terms, let's continue and look at the standard in more detail. IEC 62443 isn't one document. It's a family of documents in 4 groups. Group 1, General, the shared language and concepts. The key part being 62443-1-1. Now we move on to Group 2, Policies and People. What the asset owner must do to run a security program. And that's covered by 62443-2-1, parts 2 to 4. Then we move on to Group 3, the System. How to design and assess a secure system, risk, zones, conduits and requirements. And that's under 62443-3-2, part 3. And finally, product. How device makers build secure products, which is, yeah, you've guessed it, 62443-4-1. Right, an easy way to remember the 4 groups. Right, 1 is words, 2 is people, 3 is systems, and 4 is products. You might want to write that down as a reminder. So just to recap, 1 is words, 2 is people, 3 is systems, and 4 is products. Okay, so let's look into it a bit more detail. So 6.1, let's start zones and conduits, which are the rooms and corridors that we talked about. A zone is a group of things with the same security needs. A conduit is the control path that carries communication between zones. The whole point is if one zone is breached, the damage is boxed in and can't spread freely. Let's now look at security levels. In other words, how strong is the lock, the metaphorical lock. There's 4 levels from SL1 to SL4. Higher numbers mean stronger protection. SL1 protects against casual or accidental misuse. Accidental misuse, very much in-house, a mistake being made. So SL1 protects against casual or accidental misuse. SL2 protects against someone using simple means and low effort to try and attack your systems. SL3 protects against a skilled attacker with industrial knowledge and moderate resources. And SL4, or security level 4, protects against a skilled, well-resourced attacker, for example at nation state level. There are three flavours of SL, and this is the part that trips people up. There's SLT, which stands for, the T stands for target, which is the level you decide a zone needs. There's SLC, which C stands for capability, the level a product or system can actually deliver. And there's SLA, the A stands for achieved, the level you actually end up with once it's installed. The job is to make SLA meet SLT. The gap between them is exactly what an assessment finds. The 7 foundational requirements, or the 7 questions. Every control in a standard maps back to 7 basic questions. These are the fundamental requirements. 1. Who are you? That's identification and authentication control. 2. Are you allowed to do that? That's use control. Number 3. Is the data intact and trustworthy? That's system integrity. Number 4. Is information kept private where needed? That is data confidentiality. Number 5. Is traffic flowing only where it should? That is restricted data flow. This is zones and conduits. Now 5 is quite interesting. Is it flowing where it should? Now what's often overlooked is the wireless aspect of your systems. If it's wired, if it's data going down an Ethernet cable, you know where it's going. If it's wireless, do you know, is your data encrypted? How far is that wireless signal going? It's things that you would need to consider. Let's move on to number 6. Did we notice and respond in time? Was there a timely response to events? And number 7, is it still available when needed? In other words, that comes under resource availability. In OT, availability and safety come first. That's why number 7 matters so much here. It's the opposite emphasis to normal IT. Let's look at maturity levels. How reliably do you do it? This clears up the most common confusion. Security levels and maturity levels are 2 different rulers. Security level is how strong the protection is. Maturity level is how reliably and repeatably your organisation does the work. The 4 maturity levels. ML1. Done once, informally. ML2. There's a written procedure. ML3. The procedure is actually followed in practice every time. And ML4. It's measured and continuously improved. So the message here is don't mix the 2 up. One measures strength, the other measures consistency. When I said don't mix them up, I'm talking about security level and maturity level. So security level, how strong the protection is, and maturity level, how reliably and repeatably your organisation does the work. Let's look at who's responsible, the shared responsibility. 3 roles, and security works when all 3 play their part. The asset owner owns and runs the system. The integrator designs and builds the solution. The product supplier makes the individual devices. Nobody is secure alone. A secure device badly installed is still insecure. Defense in depth, which is layers. Never rely on a single wall. use several layers so that if one fails, the next still holds. Zones, conduits, security levels and monitoring are those layers working together. How an assessment actually flows. Define the system under construction. Remember, system under construction is abbreviated to SUC. So firstly, define the system under construction. Draw the boundary. What's in, what's out. Number 2, do a high level risk check. Is there enough risks to go further? That almost always is yes. Number 3, partition into zones and conduits. Group the equipment, map every path between groups. Assess risk for each zone and conduit. Look at each one in detail. Set the security target, SLT. Decide how strong each zone and conduit needs to be. Find the gap. Compare the target against what's actually in place today. Write the remediation plan. List what needs to change to close the gap. And finally, document everything. The documentation is the deliverable. This sequence is defined in IEC 62443-3-2, the risk assessment part of the standard. Now, I'm involved in wireless communications, so you might be thinking, well, how does wireless come into this? This is where it fits. Every wireless link, Wi-Fi, radio, such as walkie-talkies, cellular, a wireless gateway, is a conduit. It's often the conduit people forget because they can't see it. I also should add IoT, Internet of Things, sensors using wireless communications comes under it. Now, wireless paths cross zone boundaries invisibly, which makes them a favourite way in to the organisation. Assessing the wireless conduit specifically is a real gap in the market, and this is where we come in. Right. Just going to have a recap now of what we've been talking about. So, IEC, well, this is a 10-part recap. We'll number it. Number 1, IEC 62443 protects industrial control systems from cyber attack. Number 2, picture a building. Rooms are the zones, corridors are the conduits, locks are the security levels. Number 3, OT security protects physical safety and uptime, not just data. Number 4, the standard is a family in 4 parts. Remember, part 1 words, part 2 people, part 3 systems, part 4 products. Number 5, zones box in damage, conduits control what passes between them. Number 6, security levels run from between 1 and 4, and it's target versus capability versus what is actually achieved. Number 7, there are 7 foundational requirements that sit underneath every control. Number 8, maturity levels measure how reliably you work. Number 9, 3 roles share responsibility: the owner, the integrator and the supplier. An assessment defines a system, draws zones, sets targets, finds the gap. In conclusion, if you only from this listening to me talking, if you only remember 5 things, remember these. Zones and conduits are rooms and corridors. This is the core idea. Secondly, Security levels go from 1 to 4, and the target versus what's actually achieved, and the gap is to narrow the difference between the two. Number 3, availability and safety come first, and that's what makes OT different from IT. Number 4, shared responsibility. The shared responsibilities between the owner of the organization, the integrator, and who's installed the equipment and designed the system, and the supplier of the equipment. Nobody secures a wireless network alone. And 5, which is the final thing I want you to remember, wireless is a conduit too, and it's usually the forgotten one. I hope you found this useful. My name is Craig, and you can go to yesway.co.uk if you need some help with this. I hope you found it interesting. Thank you for listening.